So now that we've gotten down our nomenclature for these three new functional groups, the alcohols, ethers, and thiols, we're going to start getting into more of their properties. And so we're going to, as well as their reactions for some of them. So we're going to start with some of the important properties of alcohols. So one of the things we've already learned about alcohols is one of the most common methods for making them. And that's that we can take an alkene and in the presence of water with an acid catalyst and heat, we add water to that alkene and make an alcohol. Now for molecules, alcohols that we find common biologically, such as ethanol, we most commonly know they're made from carbohydrate fermentation. Once we get alcohols, though, we know they have many uses. Lab solvents, use them as gas additives, and many other things. Now, if we're talking about the structure of the alcohol, the most important piece of the alcohol is this highly polarized OH bond. And this highly polarized bond allows for better attraction between molecules due to the fact that it allows for hydrogen bonding. Hydrogen bonding, you recall, is an intermolecular force and a relatively strong intermolecular force. Now, what does this OH group do for the properties of an organic compound? Well, we can look at this relatively simple comparison. We're going to compare ethane ethanol, and propane. Why these three molecules? Well, ethane and ethanol we're going to compare because they have the same number of carbons. And ethanol and propane will compare because they have very, very similar molecular weights. We're going to look at two properties, boiling point and are they water soluble. So probably the easiest one on here is ethanol water soluble. Well, given that ethanol is the type of alcohol you find in drinks, clearly it has to be water soluble. The reason that ethanol is water soluble, again, is because of this polarized OH group. That polarized OH group is able to not only hydrogen bond with other ethanol molecules, but it can hydrogen bond with water. That makes it more polar and allows for it to be water soluble. On the other hand, these other two molecules, ethane and propane, they're hydrocarbons, they're completely nonpolar, and completely insoluble in water. So putting that OH group in, again, has a significant effect on solubility. But it also has a large effect on the boiling point. So remember, when we try to melt a compound or boil a compound, we're trying to pull the molecules apart from each other. And so the more tightly those molecules can hold to each other, the more energy you need to add in order to drive them apart. And so the stronger the attraction, the higher the melting point, the higher the boiling point. So Ethane and propane, both being hydrocarbons, have very, very low boiling points, -89 and -42. There's certainly a difference between them, but both of them are nonpolar molecules, and their only intermolecular force is the very weak van der Waals or London forces. Propane has the higher boiling point because it's a larger molecule and there's more surface area for attraction. But ethanol, which again has either the same number of carbons as ethane or the similar molecular weight to propane, has a very different boiling point. Ethanol, well over 100 degrees higher for its boiling point. And again, that's because of this polarized OH group. So in general, we can see very clearly from this example, hydrogen bonding is much, much stronger than London forces. But that's not to say that London forces don't matter. Because what happens as our alcohol changes? So methanol, ethanol, propanol, we could keep going. But we'll stop at 1-pentanol. And in each of these 5 alcohols, we have the OH group, which means that we can hydrogen bond. What's changing is the length of the carbon chain. And so we saw on the last page that as we added more carbons, there's more surface area, more attraction. And that's still going to be true for alcohols. The OH is still the dominant effect, but the longer the carbon chain is, the more attraction there is, and the higher the boiling point. In addition, this also has an effect on the solubility. So things like methanol, ethanol, propanol are completely water soluble. As we get up to about 4 carbons, it's only slightly soluble. And as the number of carbons increases, water solubility goes down. Now, why is this? Well, the main reason for this is even though that OH group is still there, it's still highly polar. As the hydrocarbon gets bigger and bigger and bigger, the hydrocarbon starts to become the dominant effect. And eventually, as we get to larger and larger hydrocarbon, larger and larger alcohols, that hydrocarbon piece gets bigger and bigger, and eventually it just overwhelms the effect of the OH group.